I'm now going to look at logs. All right, let's quickly once again go through rules of logs. I've got log, any base to the A, plus log, same base to the B. Now logs are exponents, so it's the same rule. If I look at it like this to give you a little bit of theory, I've got 3 squared equals 9. That's an exponential equation. I can rewrite that and say 2 is a log. It's a log. Now, log is a piece of wood, so I've got to explain exactly what happened. It's a log to the base 3 of 9. That is the same expression written as a log. Let's do one more. Let's say I say 2, see 2 again, is the log of 4 to the base 2. Now 2 is still a log, but it's different exponential expression. What am I saying here? Base is 2. Log is 2 equals 4. So in other words, logs have the same laws as exponents. What happened when you added the exponents? Yeah, you were multiplying the numbers. So I got log base M A times B. Right, same story. Log A, any base you like, P, minus log B. What did we do when we subtracted exponents? What were we actually doing? Yeah, we were dividing the numbers. So I've got log base P A over B. And finally, I call it the jump up, jump down law. Gives me log A to the power of M is the same as M log A to the P. Why? It's the same rule as the exponents. I'm raising a power to a power. What do? I multiply the exponents. What are exponents? They are logs. Let's just use this rule a little bit. Remember I told you about the magic 1 of exponents? Well, of course, we've got a magic 1 of logs as well. So let's see where the magic 1 of logs comes from. 3 to the 1 is 3. 5 to the 1 is 5. You all agree with me on that? A to the 1 is A. General case. Log form, 1 is log of 3, base is 3. Exponent, log. 1 is log of 5 to the base 5. So hey, guess what? We've got our 1 of logs. 1 is the log of A to the base A. Now, I needed to show you that because to really understand logs, you have to understand that. But understand one thing, that logs are not a huge part of the actual examination. So you will get a couple, maybe 5 or 6 marks involving logs. But where logs become very important is in log application, which comes into financial maths, which Mark is going to be doing with you. So I'm not going to do one of those, I'm just going to do a couple of questions involving logs. All right, simplify as a single log. First law is that jump up law. Right, now let's use this 1 of logs and see how we're going to use the 1 of logs. So let's say I've got log 8 to the base 2. Now, again, just like exponents, logs have got to be written in the simplest possible form. So I've got log base 2, and what's 8? 2 times 2 times 2, which is 2 cubed. Now, I can hop down. I call it the hop down into the fire and the hop out of the fire law. Right, just now we will see how we use the hop out of the fire law. Here I'm hopping in. And what law is it? It's the third exponential law, which is raising a power to a power. So I jump down and I get 3 log 2 base 2. Who is this? The magic 1 of logs. Answer is 3. Right, let's do a couple of examples using the laws. Simplify as a single log. Now, first law, I can only use my addition law of logs if I have log A and log B. So my first thing is to use the reverse of the law I've just shown you. And what do I get? Log A squared. Exactly the same as 2 log A plus log B cubed. Now they said a single log. So what am I doing? I'm adding the logs together. So what do? I multiply the numbers. A squared, B cubed. Now we are going to give you some examples in the activity where you are using numbers. But I don't think they're going to give you that in the exam because you can just cheat on your calculator. You've got a calculator, you can just plug it into your calculator and get the answer. Right, now let's look at this. This they could easily ask you. And I've been asking my students questions like this because you can't use a calculator. If log 2 is A and log 3 is B, find in terms of A and B log 12. Now, the rule tells me that when I'm multiplying the numbers, I add the logs. So this has got to be written as multiplication. So I'm going to write this as, in its prime factors, log, break it up. I've got 2 times 6, which is 2 times another 2. 2 times 2 is 4 times 3. Now, there we go. I'm multiplying the numbers, so I add the logs. So I've got log 2 plus log 2 plus log 3. Level 2 question, which gives me A and another A, 2A plus B. Now, if we look at this question here, I've got log 2 and I've got log 3. But remember the magic one of logs. I've also got log 10. Log 10, base 10. Log 10 is 1. Now, we come to this question here. Sorry about this. Let me write this nicely here. I've also got the fact that log 10 is 1. Now, I want to find log 5. Sorry. I want to find log 5. It's got to be multiplication and division. I cannot say, let's go, not log 3 plus 2. There's no rule that tells me what to do with 3 plus 2. Not. Now 5 has got to be written with these numbers here. 10, 2, and 3. Any of these numbers such that you've got either division, which means I'm subtracting, or multiplication. So take a minute to think. Of course, 10 divided by 2. So I'm going, this is the same as the log of 10 divided by 2. Rule! Great rule! Dividing the numbers, subtract the logs. What have I got? Log 10 minus log 2. Log 10 is the magic one of logs, minus log 2. And what was log 2? Let's go back and look. Log 2 is A. Done. Now, that is all I'm going to cover in actual simplification. But as I said to you, after watching this, my suggestion, pause the DVD and go. You will see these same examples written down for you with a little worksheet of about 10 examples with the solutions at the back of the book for you to actually go and try. What did we say maths is? Of course, yes. Maths is a doing subject.